So we go 9.1 recap problem. So let me read this. Let's talk about it. Let's do it. According to U.S. Census Bureau, the population proportion, the proportion, yeah, that's a good word right there, proportion of students in high school who have part-time job is 0.25. An administrator at a local high school suspects that the proportion of students at our high school who have a part-time job is less than national figure. She'd like to carry out a test, not in confidence interval, but a test at the alpha 5% significance level. The administrator selects a random sample of 200 students from the school, finds out 39 of them have part-time job. Carry out a significance test for the true proportion of local high school students is less than the national figure. All right, phantoms. Here we go. Let's think about it. All right. So let's think about the P part of phantoms. Now, I'm not going to write this out specifically, but I want to think about what is it that I'm actually looking for. What is it that I want to know? I want to know the true proportion of local high school students, and then I'm going to see is it less than the national figure. So what is the true proportion of local high school students? I don't know it. We're going to use a sample to try to figure it out. All right. So let's get right into the first one, hypotheses. You have to write this out. You have to be very specifically clear about it. Hypotheses. What are we going to set this up? Remember, up here, according to the U.S. Census Bureau, the proportion of students who have a part-time job is 0.25. And we're trying to determine if this local high school is less than that. So what we're going to say is the true proportion, P, is equal to 0.25. We're going to use that as our base. And what do we suspect? What are we hoping to see? That the true proportion is less than that national average. Do we have enough evidence to say the alternative? Right? Now, again, notice that we are using a P here and a P here, not a P hat. We do not care about the sample. We care about the true population proportion. So that's what we got to do for our H. Okay, move right into the assumption checks. Now, since we are talking proportions, we have 3 of them. These are the exact same 3 that we use for confidence intervals. So we got to do our normality check. So it's n times p is greater than or equal to 10. Now, here's the slight difference. The n is 200. Instead of using the p hat value like we did at confidence intervals, we have a claimed p value to use. So use it. 0.25, right? If you have a p-value, use it. If you don't, use p hat. Use the next best thing. It's greater than or equal to 10. All right, and then 200 times 1 minus p. Well, that's going to be 0.75. And this is going to be greater than or equal to 10. All right, are those both greater than or equal to 10? Yes, you can check them if you want. Normality checks out. Let's try our bias check. I see the word literally random sample. Okay, so that's checked out. And then third, can I use the standard deviation calculation? Well, that's an independence check. So a lot of times we're going to do the 10% rule, right? From a school. So we're going to say let's do this all in the same color. All students at the school. Is it greater than or equal to, let's see, if we took 200 times 10, that's 2,000. Do we believe it's more than 2,000? This is safe to assume from a school, and I'll be honest with you, most schools across the U.S., high schools are bigger than our high school of like 1,200. So 2,000 is definitely a safe assumption. Okay, there's that part right there. Oh, so sorry, let me go back to this over here. So we took care of the A part of phantoms. All right, what's the N part of phantoms? If I literally wanted to write out the N part of phantoms, I'm literally going to write what it is I would go into my calculator. Here's what I would do in my calculator, and I'm going to do it here in just a minute. 1 prop Z interval. Oh, not interval, sorry, that's what we did last time. 1 prop Z test. We are running a test of significance. We're still doing proportions. Proportions are always Z. So that's what's going on there. All right, let's go to the T part of phantoms. Trying to keep the problem showing, trying to keep the problem showing right up here, okay? All right, the T part, this is where we're going to show everything. Remember, we did a normality check. Why did we do a normality check? So that we can use the normal curve. So we're going to draw the normal curve. We are going to center it around the claim, which is 0.25. Now at this point, here's what I'm going to do. I'm going to take a quick pause, and I'm going to say, what is my p hat value? My p hat value is 39 over 200. Notice I haven't even used the p hat value up to this point yet. But now that we have a reason to use it, I need to find it. So 39 out of 200, let's go. 39 divided by 200, and that is 0.195. Okay, so 0.195, let's go find that on the curve. It's going to be to the left of the claim, 0.195. Now here's what you need to do. Take a look at this sign here. It is a less than sign, which means we are going to be shading less than the sample. If it was a greater than sign, you would shade greater than the sample. If it was a not equals to sign, we would need to shade both less than and then flip over to the other side of the curve and shade greater than. This is just strictly a less than, so this is it. That's what my curve looks like, okay? So I draw the curve, I shade the curve, and now I'm going to show my z-score. So here is the z-score. Z equals my value, 0.195, minus the claim, 0.25, divided by the standard deviation of the proportion. And we're always going to use the claim number in here, 0.25, 1 minus 0.25, all over n, which in this case is 200. And we're going to work that out. But I'm going to work that out in a second. Watch this. I'm going to let my calculator now do everything else for me because I'm going to go to the O, and the O is obtain a p-value. That's what O stands for. So I'm going to now switch to my calculator. So here's what I'm going to do in my calculator. Let me let me write what I'm doing in my calculator so you can follow along. Hit my stat button. Stat. Go to test. And then find, here it comes, one prop z test. Okay, so let's do it. One prop z test. What's it asking for? First thing it asks for is what is the null hypothesis proportion? In this case, let's put in 0.25. So do that with me, 0.25. X, I'm going to put in the X, that is the number of successes. That's literally how we got the number there, right? So that's the 39. The next value it asks for is N. N value, that is the sample size. Well, that's on the bottom of that fraction, the p hat that we do. So let's put in 200. And then we got to get the appropriate, the alternative hypothesis, right? So it says prop, and so it's really asked for the alternative hypothesis. And we just need the sign to match exactly what we did here. We have a less than sign. Well, let's highlight the less than sign. So I'm going to go until I highlight over the less than the null hypothesis value. So do that, hit enter, and then calculate. Okay, so let me stop. The reason I wanted to stop here is because now it's given me all the information I need to backfill in here. Okay, here's what I'm doing. I'm looking at my calculator. What is that z value going to be? Negative 1.796. Right? Again, what does this tell you? It tells you how far you'd have to travel in standard deviations to get to your value. I would have to travel negative 1.796 standard deviations to the left of the claim to find my sample. Now, p-value, let's write in the p-value. I see a p-value here. It's literally listed right under the z. It is 0.036. P-value. What does the p-value tell you? Well, not only is it how much area you shaded, but there's a 3.6% chance of getting a sample like the one we are looking at right now, or more extreme, if the true hypothesis is 0.25. Right, so that's what the p-value is telling me right now. Okay, let's do our make a decision. This is where we compared p-value to the alpha value. What alpha value they told us? Oh, there it is. Alpha value of 0.05. My p-value is less than. We would reject the null hypothesis because p-value is less than alpha value. But this is the big punch word right there. Reject the null hypothesis. All right, summarize. Here's how you summarize. If you reject, you have evidence. If you fail to reject, you do not have evidence. So we'd say this: we have evidence to suggest, really we're going to suggest the alternative hypothesis, but put it into words, to suggest the, I'm just looking at the words up here, the local high school high school's proportion is less than the national figure. And there we got it. This is phantoms. This is phantoms. Remember, you have to explicitly write out your hypothesis. You have to write out your assumptions and checks. You have to draw the curve, shade the curve, and show the z-score. You have to show the p-value. You have to make a decision, and you have to summarize. That's why we do phantoms, because we hit all the pieces we need to do.